Yes, sir. Now you can start the class, sir.
Okay, okay, ma'am. Thank you. Mm, just a second, ma'am. This notebook got stuck.
Sure, sure, sir.
So, hello everyone. My screen is visible. My screen is visible, right? So,
Yes,
yeah, we were
yes, sir.
discussing about
Yes, sir.
logarithms yesterday. Okay, okay. Thank you, ma'am. Thank you very much. So, we were discussing about logarithms yesterday. We were learning about logarithms and exponentiations. So, both of these are basically inverses of each other, right? So, in yesterday, we yesterday's class we had done some of the properties related to logarithms. Like if you take logarithm of like something raised to power m, so this m can come out to the front, like something like this we were discussing yesterday. Similarly, if you raise your base to any power, so it becomes 1 by m. So yeah, that is what we were discussing about yesterday, right? So okay, so like you have you all done some problems that yesterday I had given you? Okay, so okay, so just one more. So just one or two more problems to clear your basics, and then we'll be moving ahead. Okay. So find the domain of this function. What is the domain of this function? This is a function given to you. Tell me what will be its domain. कौन कौन आया है आज? भावना, गायत्री, आश्रिता, ओमकार इज देयर. अच्छा, चलो सही है. डोमेन बता देना यार इसका. कैसे करेंगे? How we will do it? Tell me, what are the restrictions on logarithm? If we are taking log, like log a and b, so there are some restrictions on a and b, right? Then only we can perform that log. What are the restrictions on a and b? There are restrictions on a and b, right? What are the restrictions? That a and b both are positive, and a is not equal to 1. Correct? Correct?
Yes,
What
sir.
a should be greater than? Sorry, like a should be greater than. Can you repeat? Uh, okay, no, no, there is no restriction on if a has to be greater than or less than equal to 1. There is no restriction on that. A can be less than 1 also. There is no issue. Like yesterday, I was gave you that example, right? 1 by 5 and 125. That is valid. It is valid. I can take the logarithm. Arey yaar. Okay, I can take the logarithm in that case. Okay. So yeah, tell me what will be its domain. So this x minus 2 has to be positive. So that means x has to be greater than 2. Okay. Okay. And 5 minus x has to be greater than 0, right? So x has to be less than 5. Okay. One more restriction. One more restriction. What do we have? One more restriction, that a can't be equal to 1. So x minus 2 can't be equal to 1. So that means x can't be equal to 3. So basically, x should belong from 2 to 5, but it can't hold 3. So this will be my domain of this function. Fine. समझ आया?
Yes, sir.
You got this right? अरे, okay, great. So yeah, like yesterday I had given you some sort of a problem like this. I don't know if like you have done this thing or not. So I was asking you to find its domain, right? Something like this I had given you yesterday, as far as I remember. So how what will you do it? How will you do it? See, just compare this thing, okay, to this form. Okay. So basically my B should be positive, but the issue is my B over here, that itself is a function of X. But A is 2, okay? Not to worry. A is 2. Okay. So this thing is sorted already because it is positive also and not equal to 1 also. But this thing should be positive. So my logarithm base 3x should be positive. So tell me, what are the possible values of x? What should be the possible values of x such that my when I take its log to base 3, the result is positive? Can you tell me? What is the like set of x that I can input over here so that when I take its logarithm to base 3, so it turns out to be positive? Hmm. Can you think about it once? Uh, okay, so like first just tell me this. If I'm telling is equal to 0, so what is the value of x now? Tell me. What is the value of x?
One, sir.
1, 1. Absolutely correct. 1. Okay, so just tell me one thing. Uh, okay, just tell me one thing. I will write this thing on the right side to be y. Okay, I will write this thing to be y. And okay, so basically this thing can also be written as 3 raised to y is equal to x. That's correct, right?
Yes, sir.
Both of these things mean the same thing. So I'm telling you that the value of y, this right side, is greater than equal to 0, is greater than 0. So my y is greater than 0. So tell me what will be the value of x, the set of x.
Greater than or equal to 3, sir.
Y is greater than 0, not greater than 1. Just think about it again. Y is greater than 0. So it is not necessarily greater than 1. Like it can be between 0 and 1 also. It can be 0.000000001 also, something like this. Can you think about it now? So, eh, are you there? Bhavna, Gayatri, Ashrita, tell me, tell me. See, 3 raised to y is x, okay? 3 raised to y is x, correct? 3 raised to y is x. And I'm telling you, y value has to be greater than 0. So, tell me, if y is equal to 0, so how much is x? X is 1. You told me exactly correctly. So it is just greater than this value. Now I am telling you y is greater than this value. So x will also be greater than this value because it is increasing. Now if x is increasing, if y is increasing, x is also increasing. And I'm telling you at y is equal to 0, x is 1. So definitely the domain of this will be from 1 to infinity. See, at y is equal to 0, x is 1. If y is increasing, x is also increasing. So I'm telling you that y has to be greater than 0. So at 0 it is 1. So if it is greater than 0, it has to be greater than 1. Got it?
Yes, sir. Yes, sir.
Sure. Are you sure? Okay, so just do this next problem. Find the domain of this function. No need to worry about f of x, it is y only, okay? Function is written in the form like this, f of x is equal to this thing. So you have to basically find the domain of this thing on the left side, this. Log base 3 log 4x, okay? Tell me. Or should I increase it one level further? Okay, I will do one nesting inside, one more nest inside this. Log 4, and then it will be log base 5x, something like this. Tell me. So now there is a bit of nesting. What is meant like nesting means inside one function there is another function type of thing. But no need to worry for me. Why? See, it is basically log 3 and there is something inside. Okay. So whatever is inside, I have to make it positive. I know that thing. So basically it's something like log base 4 log base 5x, right? Has to be greater than 0, right? So again, I look at this thing. I again look at this thing. So it is something of the form log base 4. Something inside has to be greater than 0. Now it has to be greater than 0. So that means this inside thing, whatever is inside, will have to be greater than 1. Correct? 4 raised to 0. 4 raised to 0. What is 4 raised to 0? It is 1. So this inside thing, whatever is inside thing, has to be greater than 1. Okay. So now tell me, what is the range of x? X will be greater than, now 1 has come over here. Okay. So it is basically log 5x has to be greater than 1. So now tell me, what is the possible value of x? क्या हुआ, समझ नहीं आ रहा है क्या? आज बहुत डल लग रहे हो. Very I feel very low energy today in you. What happened?
Not
नहीं
able to
समझ आ रहा
understand.
क्या कल कल वाले? Okay, so should I open yesterday's that slides? Okay, I will just a second. Uh, it was 17 yesterday, right? Yeah, just a second. Yeah, actually, I get your point why you are not able to understand, because earlier we were discussing about constants. Earlier we were discussing about uh, okay, just a second. Let me try to see if it can open. Okay, see, yesterday when I was telling you about that logarithm thing, if I have any log base a and x, so yesterday I had told you that there were certain restrictions what log I can take. Okay, so I am unable to open that, so I will just explain it here. See, yesterday I was teaching you like y is equal to log base a x, right? Something like this I had taught you yesterday. You remember? So the restriction here was like this can be written as, right, both these things mean the same meaning. So yesterday I had taught you something that x has to be always positive, and a can't be 0, and a also has to be positive. These were the three conditions that I had taught you yesterday. Okay. So the issue here is that earlier this a was a constant value. Yesterday we were learning about something like this, something like this, something like this. Okay. But now we have changed it. Now the problem is that this a is also varying. So something like a also belongs to like a is also a function of x. Okay, something like this. This a is also becoming a function of x. So now these three conditions will remain the same. These three conditions will remain the same. But instead of x, I will be using this thing. Instead of a, I will be using this thing. So basically, this will be my this will be my x thing input, and this will be my a, that is base. So we are just converting everything we had learned in form of numbers to everything in form of variables. Okay, just try to think of it like that. Yesterday we were learning about constants that see this was 2, this was 3, this was 1 by 5, some number, constant number. But now even this base has become a function, like it has become in terms of x. And this top thing has also become in terms of x. Okay. So like I can just give you some small problem to clarify your doubt. So I have something like x minus 3. Okay. So tell me what will be the domain of this function? Earlier we were learning about just x. Today we are learning that this x has changed and it has become a function of x in itself. Okay. A function of x in itself. So there is a function inside a function, like we used to do in chain rule. There is a function inside another function, but that was for derivative. Chain rule was for derivatives. I don't need to do that thing now, right now. So I'm just telling you that compare it to chain rule, what we studied in chain rule. What happened in chain rule was I had one function, I had another function. So I was putting this function inside this thing. Similarly, just think of it like this. I have a function. Okay. Inside that, I am putting this function. Inside that, I am putting this function. So this overall thing will turn out to be something like log base 2. Okay. Log 3, log 4x. Right? This is what is happening over here. This is what is happening. Fine. Do you get it now? Just convert everything that we were learning about numbers yesterday to the form of variables, to the terms of x. Is that fine? Tell me.
Yes, sir. Yes, sir.
Okay. Okay. Like you sound very dull. So, uh, like I'm not sure. Can you tell me what is the issue? Like you are not able to relate to yesterday's class. Is that the issue? Uh, like what we were learning yesterday about logarithm, you're not about to like you can't relate to that. Is that the issue, or like is it something else? Like you can tell me, yeah, there is no problem with that. I don't know why it is not opening yesterday's. Okay, anyways. So yeah, uh, like these were some of the basic problems. Okay, so I hope now you understand this thing. Now you understand this thing. Okay, so the base of the logarithm has to be greater than 0. Similarly, this thing, the input that we are giving in the logarithm has to be greater than 0, and the base can't be equal to 1. So x minus 2 has to be greater than 0. So x has to be greater than 2. 5 minus x is greater than 0, so x has to be less than 5. X minus 2 can't be equal to 1, so x can't be equal to 3. So when I take intersection of these three things, right? For a domain, we take intersection of all possible. So it is 2 comma 5, like anywhere between 2 to 5 minus 3. So any number between 2 and 5, but not 3 is my domain. So we come over here, log 2, and this is log 3x. So the issue here is that the input we are giving inside the function, this thing, instead of x, this is my x. Like in the earlier we were writing it something like this. So instead of x, now my x is this log 3x. Log base 3x is my x now. So I will look at this thing again. So my base is already sorted. My base is already sorted. My base is 2. 2 is already positive and it is not equal to 1. So I moved in. I'm checking b now. B, that is my input that I given the logarithm. So my b is equal to base log 3x, right? So my b has to be greater than 0. My b has to be greater than 0. So in order for my b to be greater than 0, like this thing, log base 3x has to be greater than 0. So the value of x has to be greater than 1, right? My x has to be greater than 1. Only then, when I take logarithm, it will be greater than 0. Yeah, you didn't understand this? Are you asking something?
No, sir.
Okay. Okay, okay. Similarly, I moved one step further. I did one more nesting. I did one more nesting. What did I do? Okay, so I will solve this problem. Like I will do it in a detailed method. No need to worry. So okay. So now the thing that is happening is log base 3, log base 4, log base 5x, right? Something like this is happening. So I look at this thing. So earlier, so now this thing has become my input and this thing has become my base. So my base 3 is already sorted. It is greater than 0 and it is not equal to 1. Okay, so I will move into this part. I move into this part. It is log base 4, log base 5x. Okay, has to be greater than 0. That is the condition, right? This input that I give has to be greater than 0. Just a second, I'll erase it. Okay. So yeah. So now I again look into this thing. I again look into this thing. But now my issue is I have this thing. So I will treat y is equal to log 5x. Like I will take it to be another quantity. So log base 4y is greater than 0. So that means my y will be greater than, tell me, what will it be? My y has to be greater than what value?
1, sir.
See, exactly. Y has to be greater than 1. Just like whenever there is an inequality like this, no, you can just easily raise it. Like I have 4 over here, I have 0 over here. So just raise 4 to the power of 0. Simple. Because it is an inequality and this function will increase. Like if I will increase this value on the right side, this y will also increase. I know that beforehand. So I can just directly take this power over here, like 4 raised to power 0. So it will be 1. So y will be greater than 1. Okay. Similarly, I have this thing. So 3 raised to power 0. So x will be greater than 1. Okay, correct. Has to be greater than 1. That is correct. But my y in itself, my y in itself now has x. So now tell me, I need to solve this thing. So what will be x greater than? Tell me, in order to solve this inequality. Okay, I will just write it in one more method. just assume this right thing to be z. Okay. So I can write that 5 raised to z is equal to x. Okay. And I am telling you that my z is greater than 1. So now tell me, what will be my x greater than or less than or whatever?
How it will come? So how is this game, sir?
See, I am like whatever the right side is here, na? Like I am assuming, see, I am assuming let log 5 base x be equal to z. Okay, and z is greater than 1. Like log 5x is greater than 1, right? We derived that from here, from top. So now 5 raised to z will be my x. 5 raised to z is my x. And I already know that z is greater than 1. My z is greater than 1. So tell me, what will be the values of x that I will get? My z is greater than 1. So what will be my x?
Greater than 0. Greater than
Greater
20.
than 0. Uh-huh. 25.
Greater than 5,
I'm not
sir.
talking about integers.
Greater than.
Exactly. Correct. 5. Uh, who was it? Bhavna?
Yes, sir.
Okay. See, just like think about it now. If I put z is equal to 1, my x will be 5. Okay. If z is increasing, x is also increasing. I am telling you z is greater than 1. So I have not told you that z is an integer. I guess Ashrita or Gayatri had told me 25, greater than equal to 25. I am not talking about integers over here, right? I am not talking about integers. I am talking about any real number possible. If it were only integers, your answer would be correct because greater than 1, the next integer I would go to is 2. So yeah, 25 would be correct in that sense. But think about irrational, real numbers over here. Okay. So yeah, this will be my final domain. My domain will be from 5 to infinity. Okay. So yeah, just one more problem. Bit tricky it is. So it is log base 2, log base half of x. So you need to find its domain. So like, should I solve this problem first? Or okay, so I will solve it, and one similar problem I will be giving you to solve. Okay. So see, I have log base 2. Then whatever I have inside, I don't care, na. Why should I care for whatever is inside? I will just take this quantity. I have log base 2 and this thing. So my base is already sorted. My base is greater than 0 also and not equal to 1 also. So base is sorted already. So I will take this quantity and I will apply the constraint on this. So this has to be greater than 0. Correct? So tell me, tell me. अब बताओ x का क्या सीन होगा? Tell me, like, okay, so I will just do it again for you. So I will take this thing log half x to be equal to y, and this y is greater than 0. Okay. So basically my half raised to y is equal to my x, but my y is greater than 0. So tell me, what is the value of x that I will get?
Sir, it is less than 1. X.
Correct, correct. Bhavna.
Yes, sir.
Okay. Yes, obviously. See, it is 1 by 2, na? It is lesser than 1. So if I increase its power, just think about it. If you are multiplying a number that is less than 1 with itself many times, so it is actually going nearer to 0, not nearer to infinity. If I have a number that's greater than 1 and I am multiplying it again and again, so it will grow towards infinity. But if I have a small number, half raised to x, so if I multiply it, so it will be 1 by 4, 1 by 8, 1 by 16. So it grows nearer to 0 if I try to multiply it many times. Correct? Because it grows smaller and smaller and smaller, basically. That's the point I'm trying to make. Okay, so since its base is lesser than since its base is lesser than 1, so it will behave in the opposite manner. So my value of x will belong from 0 to 1. And yeah, you made a mistake. When you told me lesser than 1, you should have mentioned that it should be greater than 0 also, no? Because see, it is log half x, something like this is there. So for this thing to be valid, so base is already sorted. Base is sorted. Why? Why is base sorted? Because see, half half is not 1 and half is greater than 0 also. And here we have x. So this x should also be positive, no? If x is not positive, then I will not be able to input on it. Fine.
Yes,
Okay.
sir.
I hope you got it. आ गया ना समझ? ठीक है. So similar one problem, log base 2, log base half, log base 3x is greater than 0. So can you think about it? Or should I give this as homework problem? Tell me, what should we do?
Students, please wait. Sir is facing some technical issue. Students, please wait. Sir is joining.
Hello, I'm audible.
Yes, sir, you're audible.
Okay, okay. No. So yeah, this problem we have over here. So can you guys think about it? So okay, so like this will be your homework. But see, please look into this. Like there we have a base that's lesser than one. Okay, so treat it. Okay, so just think about it clearly. You will be able to do. There is like not an issue. Just you have to move one step further from the previous question. From just one step, you have to move further from the previous question. So earlier we were just making two loops. Now there are three. So you will need to like just think about it. Quite similar to the one this one that we did. Okay, but just negative base is there. Okay. So yeah, yeah. Since there is not much time left. Okay. So okay. So we will just like. So I'll have you learnt about this number E? It is very useful. Have you learnt about this number E in mathematics? So okay, I will just tell you about this number. Okay, so basically it is a constant. It is a constant, just like we have pi, just like pi. Okay, so you haven't learned about it in physics. Okay, not an issue, not an issue. I will be telling you because we have just enough time to complete it. Okay, so see, like what is pi basically? So I will just tell you the basic, like you know obviously what pi is, right? I don't need to tell you that. So so this is these are my three circles. Okay, so let us name it its radius as a. This is g. Okay, this is n. Okay, so this one was drawn by Ashrita. This one was drawn by Gayatri. This one was drawn by N Ashrita. Okay, sorry. I used your name again. Oh, sorry. Okay, so I will name it as B. So this is Bhavna. Okay. Okay, okay. Just a second. So this one was drawn by Bhavna, this by Gayatri, this by Ashrita. Okay. So the ratio of their circumferences to their diameters will always be equal to a positive value whose value is an irrational value, turning out to be something like this. Okay. No matter how big the circle is or how small the circle is. Okay. Right? That's true, right? It won't be that, okay, Bhavna has drawn a circle, so the ratio of its circumference and diameter will be something else. Gayatri has drawn it, so it will be something else. Ashrita has drawn a bigger circle, so the ratio of its circumference to its diameter would be something else. It won't be like that, right? It will always turn out to be pi. It will always be pi. It will always be a constant number somewhere around 3.14. Okay. So similarly, what happened one day, I will tell you. What happened one day was many scientists, all the mathematicians and scientists met one day. Am I audible?
Yes, sir.
Okay, okay. So what happened was that one day all mathematicians and scientists met together. Okay. So they were thinking about a problem that no one that they were not able to solve. Okay. So the problem was what? They were thinking about a function of x. Okay. A function of x whose derivative at every point was equal to the value of function at that point. In other words, I can also say derivative at every point is basically what dy by dx. Okay, so I have a function y that only depends on x. Okay, y of x. There is something like f of x. So I have y as f of x, y a function of x. Okay, whose slope at every point. Derivative means basically slope, right? Slope at every point. Slope at any point was equal to the value of function at that point. Okay. So they were thinking about this function क्या कि यार ऐसा कैसा function draw करें कि जिसका slope and value both should be same. Okay. ठीक है. तो उनमें से एक चालाक बंदा था. There was a clever person. So he told me he told that sir you can't solve it theoretically. So there is not an issue. What do? You start plotting its curve. Like you take a curve and you try to plot it. You directly start plotting this curve. So what he did, he was clever, na? So he started plotting this thing. So when he plotted it, the curve turned out to be something like this. It is passing through 0, 1. Okay. The curve turned out to be something like this. So can you tell me which type of curve it is? Like yesterday we had learnt about exponential curves, right? Are you there? यार ऐसा लग रहा है आज तो सो ही रहे हो बिल्कुल मतलब सब. Everyone is sleeping today it seems. See, all mathematicians and scientists, they gathered at a day, okay? They gathered somewhere, wherever they wanted to. And they were trying to basically devise a solution that is there a curve possible whose slope at every point was equal to the value of the function at that point. So basically, if I'm taking a tangent over here, its value is 0, 1. So its slope will also be 1. Similarly, if I take a point like this, whose y coordinate is 2, so its slope will also be 2, right? They were trying to devise the curve something like that. So basically, when they tried to design such a curve, so the curve turned out to be something like this. Okay, infinitely long. Okay. So we know that this thing is definitely of this form. We had learned in exponential functions yesterday, right? We had learned
Yes.
exponential functions yesterday, right?
Yes.
Okay.
Yes.
Yeah. So, like, there are infinitely many possible values of A here, but satisfying to this condition, satisfying to this condition, they found out the respective value of A, and this value of A turned out to be an irrational number. Okay, this irrational number and its value was somewhere around 2.718, something like this. An irrational number means it is like continuing till like infinite decimals. Okay, and they call this number E, natural constant number. So now you know what E means. Now you know what E means. E is basically an irrational constant whose value is somewhere around like 2.718, something like this. It is there. Okay. But the speciality of this function, it has a very special thing attached to it. Yeah. So just some more values I will give you. So it is 28183, something like this. Okay. So this is the speciality attached to this curve, that when I plot y is equal to e raised to x, so the slope of the tangent at every point, the slope of the curve at every point is equal to this y itself. So in other words, I can say dy by dx, y is equal to e raised to x. Okay. So dy by dx is also e raised to x. This is the property, or this is the, like, what I can say. This is how basically e, the number e, was derived. Just like we had pi. You draw any curve, you draw any circle, the ratio of its circumference and diameter will always be equal to this particular constant value, 3.14, whatever that was, irrational number. Similarly, I draw such a curve whose slope at every point should be equal to the value of function at that point. So that's how I get e raised to x. Okay. Similarly, what happens is, like, I take ln ax, right? If I replace a by e, if I replace a by e, this thing is called my natural logarithm. Okay. Just a term, it is represented like this: ln of x. ln of x. ln basically means natural logarithm. When its base is e. So how will the graph of e raised to x look like? Obviously, it will be like this only. It will be of the form a raised to x only. It will pass through 0, 1, but it will have a special property attached to it. The special property attached with the curve will be that if the slope at any point of the curve, I take this thing, I take any point I take. So the slope of the tangent that I will get will be equal to the value of y, where the tangent I have put. Okay, that is the speciality of this curve. So if y is equal to e raised to x, so its derivative is also e raised to x. Similarly, I have ln of x, natural logarithm, if I have this thing. Okay, so just remember one thing. During integration, can you tell me what is the integration of this thing? It's x raised to n plus 1 divided by n plus 1. I had taught you this during integration, right? But along with that, I had also told you that n can't be equal to minus 1. Because if n is equal to minus 1, this thing will turn out to be not defined, right? It will be divided by 0, so it will be not defined. So now, in the case of n is equal to minus 1, that means integral x raised to minus 1 dx, or I can write it as integral 1 by x dx. So the integral of 1 by x dx is basically ln mod x. Okay. So this is a special case of integration and differentiation, both. The integral of 1 by x, if I'm trying to integrate 1 by x, okay, so the curve 1 by x looks something like this: 1 by x, y is equal to 1 by x. So the integration of this curve is basically ln of mod x. This is how the curve looks. Okay, like, no need to worry about that you don't know how the curve looks. No need to worry about that. You will learn it in later. I'm just telling you that the integration of 1 by x is ln of mod x. Fine. Okay. So I guess today there will be some practice problems that I will be giving you, because I see like there is an issue. Uh, I don't know what happened to you today. Like, I don't feel that energy generally. That generally I do. Okay, so yeah, I will be just ending the lecture. If you have any doubts, you can ask me. Till now, any like अभी तक जितने भी क्लासेस हुए हैं उनमें कोई डाउट है या आज की क्लास में कोई डाउट है तो पूछ लो यार. भावना, गायत्री, आश्रिता, क्या हो गया आज?
Sir,
Yeah, tell me.
what is the domain of log f minus x
Log x, like
x minus 2? Log 5
sorry,
minus
sorry.
x to the
Domain
base
of
5 minus x to the base x minus 2, sir.
5 minus x and x minus 2, something like this.
Yes, sir.
Like we have done this thing here, na? Is this what you're talking about?
Yes, sir.
Is this thing? Okay, so like see the base, see just look at this thing log a b. Okay, so the base has to be greater than 0, the input or the b has to be greater than 0, and the base can't be equal to 1. So uh, x minus 2 has to be greater than 0, so x is greater than 2. 5 minus x has to be greater than 0, so x is less than 5. X minus 2 can't be equal to 1, so that means x can't be equal to 3. So I will take intersection of these three. So greater than 2 means 2 to infinity. Basically, it means 2 to infinity. This means minus infinity to 5. And this means like intersection of these things. And I can't take 3. So basically from 2 to 5, but I can't take 3. X can't be equal to 3. Right? Chalo, to jaldi jaldi, just one thing we will do. I have taken y is equal to e raised to x. Can you tell me what will be its domain? E is just a constant, just treat it like a constant. Tell me what will be its domain? What are the set of values that you can put in this x? अरे यार कल exponential functions पढ़े थे ना, y is equal to a raised to x. So just I'm just putting a specific value of a over here. So nothing will change. Domain is all obviously minus infinity to infinity, but range is from 0 to infinity. It can
Zero to
only
infinity.
return positive values, right? क्या हो गया यार आज? बिल्कुल ही मतलब did something like happen in some previous class or like something related to school or something? Okay, anyways, like I'm not sure like what happened. If you are ready, like you can share to me also like, what happened. Like I did not feel any energy in class today. भावना, गायत्री, आश्रिता, बता दो क्या हो गया? What happened today?
कुछ भी नहीं, sir.
Ma'am, please turn off the recording.
Yes, sir, 1 second.